Welcome to the deep dive. We're here to unpack those complex topics, give you those real aha moments. Have you ever been on a plane, maybe just looking out the window, feeling that quiet confidence? That feeling that everything's safe. Well, that feeling isn't just about the amazing engineering that gets us off the ground. It's really built on this huge, intricate, and often unseen system.
It really is. Most people, they see the plane, the pilots, the cabin crew, the visible stuff, but behind all that, there's this invisible architecture. It's a framework of rules, really meticulous procedures, and some incredibly dedicated people working constantly to make sure every single flight is safe, start to finish.
And that is exactly what we're diving into today. We're looking at that hidden framework, specifically the world of aviation continuing airworthiness. We'll be guided by the European Union Aviation Safety Agencies, that's EASA set of rules. Our goal for you, our listener, is to kind of pull back the curtain on how aircraft are kept safe and reliable after they leave the factory, throughout their whole life. It's complex, yeah, but genuinely fascinating. Okay, so let's start at the foundation. EASA's Easy Access Rules, or EAR. What exactly are these? How do they work?
Okay, so think of EASA's e-rolls like a massive, constantly updated digital library. Really, it's a single online system. It structures, shares, and stores all the essential aviation safety regulations. Now, these easy access rules books, the ER books, they're basically consolidated, more user-friendly versions. They pull together the EU regulations and related EASA decisions, makes them easier to navigate. And crucially, they're updated all the time. Aviation safety isn't static.
Right, constantly evolving. And you mentioned there's one core regulation that's key to today's discussion.
Yes, exactly. While there are many important rules, regulation, EU, No. 132 Salv 1 2014 is fundamental. It's really the heart of continuing airworthiness,
Yeah.
which basically means ensuring an aircraft stays safe and, well, fit to fly throughout its operational life, not just when it's brand new. It's about the long haul.
Continuing airworthiness.
Mhm.
Okay, it sounds quite formal, but what does it actually cover? Is it just for the big airliners, or does it go wider?
That's a really good question because the scope is surprisingly wide. And the key thing here is this unwavering commitment to safety across all kinds of flying. We're not just talking Boeings and Airbuses. These rules cover everything from, say, small sailplanes, even hot air balloons.
Hot air balloons, seriously.
Yep, even those. All the way up to complex powered aircraft, big helicopters, even things like tilt rotor aircraft. It just shows that safety is the baseline, no matter what you're flying or why.
Wow, okay. That's a massive range. So I'm guessing different aircraft, different types of operations, they probably have slightly different rules.
Exactly. That's where the different parts come in. You can think of them as specific chapters in this big rule book. You've got Part M, Part ML, Part T, loads of them. Each one lays out specific requirements tailored to the aircraft type and how it's used. So it's not one size fits all. It's very targeted.
Okay, that makes sense. So we've got the rules. Now, let's get practical. What does the actual maintenance look like on the ground? This brings us to the maintenance organizations, the approved outfits doing the hands-on work, right? Like under Part M, Subpart F, or Part 145. What do they need?
Yeah, their requirements are very specific, very focused on quality, precision. You need proper facilities, obviously, clean storage areas for parts, well ventilated, kept at a steady, dry temperature. You don't want condensation or anything like that causing issues down the line. And proper hangar space, of course, considering the weather. All their procedures, what they can work on, how they do it, it's all laid out in their maintenance organization manual, the MOM.
The MOM, right. Now, something that caught my eye. Fabricating parts. I mean, you'd think only the original manufacturer makes components. Can these maintenance places actually make their own?
That's a sharp question. And yes, they can, but only under really strict conditions. They might make a specific item, maybe for an overhaul or a modification job they're doing in-house. It's not like they're becoming manufacturers selling parts. It's more about having the capability to complete a specific critical task efficiently, but only if they have the approved design data. Safety first, always.
Got it. So it's for their own use, basically. And all this work, it needs a plan, doesn't it? That blueprint. The aircraft maintenance program, the AMP.
The AMP is absolutely crucial. It's the roadmap. It details every required maintenance task and, importantly, how often each task needs doing. It has to follow the instructions from the authorities and the aircraft designers. What's interesting is that many AMPs now include reliability programs, especially for aircraft using what's called MSG logic, maintenance steering group logic, or for components monitored by condition. This helps make sure tasks are effective and done at the right time. Operators can even suggest doing things more often or adding tasks based on their own data or where they fly. It's adaptable.
Okay, but what about when things don't go to plan?
Yeah.
Defects happen. How are those handled, especially serious ones?
Yeah, good point. If there's a defect that seriously hazards flight safety, well, that's a full stop. It must be fixed before the aircraft flies again. No exceptions. The certifying staff, they're the ones signing off, make that call. They often use something called a minimum equipment list, an MEL, which outlines what can be safely inoperative for a limited time, but serious safety defects, no go.
And controlling the components themselves sounds just as tight. You can't just grab any part off a shelf.
Absolutely not. A component only goes on an aircraft if it's certified as satisfactory and it's listed in the official maintenance data. And if a part is unserviceable, it gets clearly tagged. The tag shows its history, time in service, known defects, if it's been exposed to anything bad. Then it's stored securely away from the serviceable parts. No chance of mixing them up.
Now, this next bit really highlights the safety focus for me. The mutilation of components. What is that? It sounds quite drastic.
It does sound dramatic, doesn't it? But it's a powerful illustration of the safety culture. Basically, unserviceable components that cannot be repaired. Maybe they're damaged beyond fix or they've hit their life limit, they must be mutilated. This means physically making them permanently unusable for their original job. Like stamping them, spraying them bright orange, drilling holes through them, even sawing them in half sometimes. The point is to make absolutely certain that this faulty part can never, ever be mistaken for a good one and find its way back onto an aircraft. It removes all doubt.
That really paints a picture. Okay, let's shift from the hands-on work to let's call it the management layer. Continuing airworthiness management, the CAMO's continuing airworthiness management organizations. What's their main job?
CAMOs, yeah, under rules like Part M, Subpart G, they are absolutely pivotal. Their job is to manage the ongoing airworthiness of aircraft. It involves a lot. Developing and getting approval for their own big manual, the CAMI Continuing Airworthiness Management Exposition. They oversee the contracts with the maintenance teams we just talked about, and they conduct these really thorough airworthiness reviews. They're like the strategic health planners for the aircraft.
And each CAMO needs an accountable manager. Who is that usually?
Yeah, the accountable manager is typically someone very senior, often the CEO. They have the ultimate financial and operational responsibility for the camo. They might not be a maintenance expert themselves, but they must ensure the camo has the resources, the funding, everything it needs to do its job safely and follow the rules. They're the final backstop.
Okay. And then within the CAMO, you have the Airworthiness Review Staff, ARS. Highly specialized people, I imagine.
Oh, definitely. Highly specialized, highly critical. The ARS team does a two-part review. First, a deep dive into the documents, all the aircraft records, its history, a paper trail check. Second, they do a physical survey. They actually go and look at the aircraft, make sure it matches the records, check its condition. Based on all that, they issue or recommend the Airworthiness Review Certificate, the ARC. That's the formal thumbs up saying it's airworthy. Sometimes they can also issue permits for specific non-commercial flights. It connects the paperwork to the actual metal.
And speaking of paperwork, or I guess digital trails these days,
Yeah.
The record keeping must be intense.
Intense is a good word. Incredibly comprehensive. The regulations demand records for, well, everything. Current weight and balance calculations, the status of all airworthiness directives, ADs, those mandatory safety fixes from authorities, every modification, every repair, proof you're following maintenance program. For commercial flights, there's a mandatory technical log system too. Records every flight, any maintenance done. And for parts with a fixed lifespan, life-limited parts, they track the limit, how much life has been used, how much is left, down to the flight hour or cycle.
This is where that invisible framework really clicks into the digital age, isn't it? Protecting those records.
Absolutely paramount. And modern systems are incredibly robust here. Digital records have to be on secure systems, protected from, well, everything you can think of. Fire, flood, heat, accidental deletion. And here's a key thing. There must be at least one backup system updated within 24 hours. And ideally, that backup is stored somewhere else entirely geographically remote, just in case. Plus, access is tightly controlled. You can't have unauthorized changes. The data's integrity is just as vital as the physical aircraft's integrity.
Okay, so we've got the rules, the systems, the data, but it all comes down to people, right? Who are the folks actually doing this work and signing off? Let's talk about the human element. The
That's-
qualified people, the training,
Yeah.
certifying staff.
Right, the certifying staff. These are the individuals holding specific aircraft maintenance licenses, usually under Part 66 rules. There are different categories A, B1, B2, B2L, B3CL, each with specific privileges. For example, someone with a Category C license can sign off the entire aircraft as ready for service after major base maintenance. They rely on the detailed work signed off by other B1 and B2 specialists, but they give the final release for the whole machine. Huge responsibility.
And becoming one isn't easy, I take it. It's not just a weekend course.
Not even close. There are demanding basic knowledge requirements, modules covering maths, physics, electrics, electronics, aerodynamics, human factors, aviation law. The list goes on, and different levels of understanding are needed for different license categories. On top of that foundation, you need specific type training for every aircraft model you work on. That often involves simulators, maintenance simulation training devices, MSTDs, plus practical, supervised on-the-job training, OJT. Then a final assessment. It's a serious commitment.
So generally, maintenance needs these licensed engineers. But you mentioned earlier, are there any exceptions? Like, can pilots ever do their own maintenance?
Ah, yes, that's a really interesting point, and it often surprises people. There is an exception for certain pilot owners, mainly for smaller, less complex aircraft. Under Appendix 7th, if you own and fly, say, a small plane under 2,730 kilos, or a single-engine helicopter or a sailplane, you can perform certain listed maintenance tasks yourself. Things like changing the oil, cleaning filters, basic fabric patches, maybe replacing certain simple nav or comms units. But there's a catch. For some tasks, if you do them, you might be restricted from flying under instrument flight rules, IFR, afterwards, unless a licensed engineer signs off too. So it's limited, but it shows a tailored approach for general aviation.
That is interesting, a bit of flexibility there. And all this complex training comes from specific organizations.
Exactly. Maintenance training organizations approved under Part 147. They're the ones certified to deliver the basic knowledge courses, the type training, and conduct the exams. They use all sorts of methods now: lectures, practical work, multimedia, simulators, even mobile learning tools.
And I assume the oversight on the training schools is just as tight.
Oh, absolutely. You have examiners present during all exams, which are a mix of multiple choice and essay questions to make sure everything's above board. And the competent authorities, the regulators, they regularly sample the exam papers and observe the training. It's all about maintaining that high standard for the people who keep aircraft safe.
Right. So you've got the rules, the work, the people, the training. Which brings us to the ultimate guardians, the watchdogs. Oversight and enforcement. The competent authorities. What's their core role here?
Their role is crucial. They are the regulators. They issue the approvals for all these organizations, maintenance, KMOs, training schools. They conduct ongoing oversight through audits, and they enforce compliance. They hold the entire system accountable to the EISA framework.
And the people doing that oversight, the inspectors, must really know their stuff.
They have to. Inspectors typically have years of practical industry experience, deep knowledge of the regulations, and critically, they get ongoing training themselves to keep up with new technology, new rules, new safety thinking. It's essential they stay current.
You mentioned audits, including unannounced ones. How does that work?
Yes, their oversight programs are planned, often risk-based, looking more closely where risks might be higher, but they absolutely include unannounced audits. This ensures organizations maintain standards all the time, not just when they know an inspection is coming. If they find something wrong, it's classed as a finding.
And there are different levels of these findings, level 1 and level 2.
That's right. A level 1 finding is the most serious. It indicates a significant noncompliance that could directly impact flight safety. It requires immediate action from the competent authority. They might suspend or revoke part or all of the organization's approval right away until it's fixed. A level 2 finding is still serious, but maybe less immediately critical. The organization typically gets a set period, maybe up to 3 months initially, to propose and implement a corrective action plan. The authority has to agree to the plan. It's a structured way to get back into compliance.
Okay, and tying back to something we discussed earlier, these authorities, or the CAMOs they approve, issue the Airworthiness Review Certificates, the ARCs.
Yes, the ARCs are key documents. Issued by the competent authority or an approved CAMO, they certify that, after a thorough review, the aircraft meets all airworthiness requirements. They're valid for a specific period, usually a year. And an interesting detail, the review can be done up to 90 days early without losing the anniversary date. Just gives operators flexibility for scheduling the review around their operations.
One last area. How does this apply globally? What about aircraft registered outside the EU but flying for EU airlines?
Ah, that's where specific rules like Part T come into play. It deals with continuing airworthiness for aircraft registered in third countries' non-EU nations when they are dry leased in by an EU air carrier. Essentially, the EU camo managing that aircraft needs to understand the rules of the aircraft's home country and ensure maintenance meets both those requirements and EASA standards performed by appropriately qualified organizations. It extends that safety net across borders.
Wow. This has been a genuinely deep dive. We've uncovered so many layers of this invisible architecture of safety,
Mm.
from the really granular detail like component mutilation, making sure bad parts stay bad, right up to the high level oversight and the absolute vital role of highly trained people. It's a huge ongoing effort.
It really is. And hopefully, understanding a bit about these regulations gives you a much deeper appreciation for just how seriously aviation takes safety. Every single rule, every procedure, every check, no matter how small it seems, is part of this incredibly robust system designed to keep flying secure. It's built on vigilance, constant learning, and never taking safety for granted.
Absolutely.
Hmm.
So next time you're on a flight, maybe think beyond just the wings and engines.
Mm.
Consider that whole unseen world of rules, rigorous training, meticulous records, and constant oversight that keeps that aircraft safely in the sky, always adapting. It really makes you think, doesn't it? What other complex systems in our world, maybe outside of aviation, could benefit from having such a clear, demanding, and constantly evolving framework for continuing integrity? Something to ponder. Thanks for joining us on the Deep Dive.